Radical functions are functions that have the variable underneath a radical. Now that radical could be a square root or a cube root or a fourth root, and depending on what kind of root it is, the graph is going to look a little bit different. If it's an even root, it's going to have a look that's something along the lines of what we see here, where it's a half of a sideways parabola. If it's an odd root, like a cube root or a fifth root, then it's going to be a continuous graph that looks more like an S-curve, so it'll kind of extend more like this. But for our purposes, we're just going to be concentrating on square root functions. Now, we can apply transformations to square root functions just like we can to any other type of function, whether it's a quadratic or absolute value or anything else. And so those functions have those transformations have the same impact on a function. We can translate the graph horizontally with a number added or subtracted inside of the radical. We can translate the graph up and down with a number added or subtracted on the outside of the radical, and then we can dilate the graph, meaning we can stretch it or we can shrink it in the vertical direction with a coefficient on the outside of the radical. But in order to be able to apply those transformations, we have to understand what the parent graph looks like. And so it may be helpful for us if we were to make a t-table of possible values that we could plug in for x and see what outputs those generate. Now we're only going to be dealing with real numbers, so I can't plug in any negative numbers for x into the square root of x. The smallest number I could plug in is 0. And if I plug in 0 for x, the square root of 0 is 0. And so we can see that our graph starts right here at the origin. We don't have any points to the left of the y-axis because those would be for x values that are negative, which we can't have. Now the next number that we can plug in, let's say, is 1. So if I plug in 1, the square root of 1 is just 1. And we're not using a plus or minus here. We only take a plus or minus, or put a plus or minus in front of a square root if we're solving an equation. But in this context, we're just going to take the principal root, the positive root. Plus, if we had put a plus or minus in front of it and gotten two outputs for the same input, we wouldn't be looking at a function. So for that reason, we're only going to take the positive outputs in this case. So we plug in 1, we get out 1, so we can see that point right there. Now we could plug in 2 or 3 in for x, but those would be inconvenient numbers in terms of graphing because they would not result in integer values for the outputs. So if we plug in 2, the square root of 2 is not an integer, it's like 1.4-ish. But if we did do that, there we go. So we can see that that's approximately where the graph is located right here. Now, the next number that would be easy for us to plug in would be the next perfect square, which would be 4. So if we plug in 4, we get an output of 2. Square root of 4 is 2, and we can indeed see that our graph goes through the point 4, 2. And then kind of following that same idea of only plugging in perfect squares in for x to make it easy to generate the points, the next number it would make sense for us to plug in would be 9, and if we take the square root of 9, we get 3. So we can see our graph is going to be going through that point right there. And so in other words, we've built this parent graph, and we should remember what this numerical pattern is, similar to how we can do so for other functions, where from our starting point, right here at the origin, we're going over 1, up 1, over 4, up 2, over 9, up 3. So as I pointed out from the very beginning, we have limitations as to what kind of numbers we can plug into a square root function. We can't plug in a negative number or something that results in taking the square root of a negative. We can take the square root of 0, we can take the square root of positives, but we can't take the square root of a negative. So what that means is, unlike some other functions like linear functions or polynomial functions, we have limitations as to what kind of numbers we can plug in as inputs, meaning we have restrictions on the domain. So to figure out what numbers we're allowed to plug into a radical function, a square root function, we're going to take whatever is underneath the square root symbol, we're going to ignore everything else, just take the part that's underneath the square root function, and then we're going to set that greater than or equal to 0, because we're only allowed to take the square root of 0 or positives. So as long as the expression that's underneath the radical ends up being greater than or equal to 0, then we're in good shape. We're plugging in numbers that we're okay with. So I'm going to subtract 6 from both sides to solve this inequality. And so then we get x is greater than or equal to -6. So that means that our domain for this function we can describe as just being x is greater than or equal to -6. As long as we plug in numbers -6 or bigger, then we're going to get real number values as outputs, which is what we want. For the next one, like I mentioned already, we're only worried about what's underneath the radical. So the 1/3, although that affects what the graph looks like, is not our concern right now. This -8 that's on the outside is also not part of our concern. All we're worried about when we're trying to figure out the domain is that the numbers that we plug in for x result in 0 or positives underneath the square root symbol. So I'm going to take that -2x plus 1 and I'm going to make it greater than or equal to 0. So we do this every time when we're trying to find the domain of one of these functions. So I'm going to subtract 1 from both sides. I'm going to scroll down a little bit to give us a little more room. So that gives us -2x is greater than or equal to -1. I'm then going to divide both sides by -2. Now if you'll recall, when we divide both sides of an inequality by a negative, we have to flip the inequality symbol. So we're going to end up with x, so it's going to turn around and be less than or equal to, and then -1 divided by -2 is +1/2. So our domain, the numbers we're allowed to plug in for x into this function, are all those that are less than or equal to 1/2. And so as an example on this one, if I took a number less than 1/2, like 0, and I plugged it in, -2 times 0 is 0, 0 plus 1 is 1, square root of 1, I'm allowed to do it. So I could keep on going and figure out what the output is. On the previous question here, we had a domain that said x had to be greater than or equal to -6. So as long as I pick a number that's bigger than -6 and plug it in, it's going to work. But if I picked a number that was smaller than -6, like -10 for example, -10 plus 6 equals -4, and if I try to take the square root of -4, I'm not going to get a real number. And when we're graphing functions, we want to make sure that our functions, all of our outputs are real. So therefore, we have restrictions on our domain. We have limited values for x that we're allowed to plug in order to make that happen.